Okay, so as we've already mentioned, Scala cannot either be compiled or interpreted. So we're going to take a closer look at the Scala interpreter here. So at a terminal, just typing Scala again gets us back in to the interpreter. So the interpreter is used to evaluate expressions without having to compile them. So that can be something simple like this, where we're not assigning the return value or the result to any variable. We're just having the expression evaluated and returned to us. You can see here that every expression that is evaluated is given a result ID. So what else can we do here? We can assign results of expressions to variables, which we've done here. We use the keyword var, which indicates that we're declaring a variable here. Again, notice via type inference, we're not telling the runtime what data type our variable is. It's able to determine that we're dealing with integers here. So it evaluates 5 plus 5 and assigns the return value to variable A, which has data type integer. So if we take a look at something like this, again, inference tells us that, or tells Scala that we're mixing integers and strings, which we can't perform arithmetic on. So it interprets the addition operator as concatenation here, returns a new string to us that's 1 and hello concatenated. Same thing again. Excuse me. So we can also refer if we have an expression evaluated that we don't assign to a variable, such as here, we can actually refer to the result ID in the interpreter. So if we do something like this, this is evaluated and assigned to this result ID here. We do something like this again. We can then refer to those results and use them in computation in the interpreter. So if we did something like this, that's also valid. So while Scala doesn't have the boilerplate that Java does, if we look at the Hello World program that we saw in the previous video, we see here that there's obviously much more than just the print statement. In the interpreter, however, we can bypass even the minimal Scala boilerplate and just accomplish similar things with more concisely. So we've talked. You've seen var, which is the keyword for defining variables in the Scala environment. Scala also provides support for functional programming, and as such, supports and even promotes the idea of immutability. So instead of, in Java where we'd use the final keyword, Scala has a shortcut for that, and instead of using var to define a variable, we use the keyword val to define a variable that is immutable. So it's actually, val stands for value. So we'll try this here, val d, and put hello there, assign hello to it. Now if we try to change d to something else, we're not permitted. Reassignment to vals are just not even a possibility. Excuse me. So let's look at the formal definition of assignment in Scala. We've seen var or val are the keywords that we use for two different types of assignments. So what we have been doing is var and then a variable name and assigning it something. So while inference has been able to determine the data type that we are assigning, that's something that we don't have to abide by that. We can explicitly tell the Scala runtime the data type that we intend to create. So the formal definition of an assignment statement is the word var or val. So here we'll use try val, followed by a variable or a value name. So, and then optionally we can use a full colon, and we can give the data type that we explicitly are creating. So in this case, it's a string followed by an equal sign and the value. Now, because of Scala's flexible syntax, we can use other Java conventions if we want, or if we're more comfortable with them, such as a semicolon. Statements don't require a semicolon in Scala. However, they allow them, and it makes absolutely no difference whatsoever.